Now, let's take a look at number one, example number one. So we have a function, okay? Now, can you go ahead and make a graph of this f of x? Okay, can you go ahead and make a graph on the picture right here down below? 4x plus 2, okay? Can you make a few dots and then draw a straight line to illustrate the linear function? So if you do this right, by the way, what form is this? Slope intercept, right? What's the slope? For the y-intercept is 2. Okay. Now this is why you want to know the form, because you can extract information. So so that means you have a line, a linear line that passes through. Oh, hold on. I think I miscounted something. Oh, yeah, this is a mistake. All right, so so right here, so you have a pretty steep line. Okay, you have a pretty steep line to draw, passing through a y value of 2 at the y-axis. Okay, and of course you have these values to help you out. So that's easy. Okay, that's easy. Now we talk about what an inverse is. Okay, so practically they cancel each other out. Now we're going to find out what an inverse is. And there are a few ways to approach this, the how question. Okay, this is not the what, this is the how. How do we find the inverse? Okay, now if you read the definition at the top, go ahead, take a moment. Okay, look at it again. It says what? It interchanges or swaps the input and output values of the original relation. What does it mean? That means basically for the inverse, we're going to exchange the xy values. So it was 0, 2, and now it becomes 2, 0. It was 1, 6, and now 6, 1. It was 2, 10, and now 10, 2. It was -1, -2, and now -2, -1. It was -2, -6, and now -6, -2. Okay. So we're addressing the how. How do we find the inverse? So one way to do it is to just swap the xy values, and then you can go ahead and make a plot. Okay, you can go ahead and use this as a plot. Okay, so you have a line that goes like this. Okay, so we'll say, oh yeah, so basically your new x values are your previous y values. Okay, your new y values are your previous x values. So that's why the graph looks something like this. Okay, what's the slope of this graph, the new graph? Can you tell the slope? 1/4, right? And 1/4, slope is 1/4. And what's the y-intercept? That would be -1/2. Okay, I think it's it hits the y-axis perfectly at -1/2. So if you write this equation, we're going to write it as 1/4 x minus 1/2, right? And since it's called the inverse of x, being the original function, this is how we would write it. You would put the -1 like a superscript next to the f, okay? And that shows what an inverse is, okay? So, so if you have the points, you can actually use the points to write an equation, but we are going to use a more sophisticated method to find out the inverse in a moment, okay? Which is our part B. Part B, it's how to find the inverse of f of x algebraically. So we found out the inverse, the graph of the inverse by just switching the x and y. But how do we do it algebraically? So this is the how, and you want to follow me tightly. So let me go ahead and write down the original equation first, okay, so that I don't have to go back and forth. And I would suggest you to do that first. Now, for f of x, you may go ahead and replace the f of x with the letter y. That they pretty much mean the same thing, so we can replace it. Okay. Now, here is the most important step. Just like what we did with the xy values, we swap them, right? What are we going to do algebraically here? We are going to swap them as well. So once you have the x and y in front of you, you will go ahead and, just literally swap them, switch the x and y, and then you are going to solve for y again. So what you want to get the y by itself. So you first subtract 2, right? You first subtract 2, and then your new y, it's going to be x minus 2 over 4, which is like x over 4 minus 2 over 4. That would be x over 4 minus 1/2. That's exactly what we had earlier from the graph. Okay, so you can say x over 4, or you can say 1/4 times x minus 1/2. That is your inverse. Okay, so to find inverse algebraically is extremely straightforward. You just need to switch the x and y and get y by itself over again. And that will be it. And then you would go ahead and use the definition of the inverse to prove two functions are inverse of each other. So, so it's like earlier, we are expecting to see that f of g of x, and we are expecting to see g of f of x, okay? Now, we will temporarily consider this as g of x. We just kind of changed name for the moment. So we would say, hey, basically, what we're saying here, it's f of x, it's 4x plus 2, and g of x, which is the inverse that we just found out, 1/4 x minus 1/2. Could you go ahead and show the composition? Okay, could you go ahead and show the composition? Putting g into f and putting f into g. And we say, sure, let's go ahead and do this. Let me go ahead and change the color a little bit. Just blue. And then we say, all right, f of g of x. Now, this is how I want to show you so that you understand what's going on. Because I understand that even for pre-cal students, when they see composition, they struggle. That's how you look at it, all right? Function f is 4x plus 2, right? Now you are getting ready to put something into the x in the f function. And what are you putting in? You're putting the function g that you had earlier. Okay. So that's how we know, oh yeah, that's what you have. And then you will distribute the 4 into the parentheses. So that becomes just x minus 2 inside the parentheses after distribution. And then you plus 2 on the outside, that hasn't changed. And then at the end, you just have x at the end, which is very encouraging, okay? Meaning that we have done something right, likely. And then you have to put put f of x into g of x right here. So where's the g of x? G of x is right here. And then to put things into the g function, we would put the function f into the g function, okay? And then you will distribute the 1/4 into the parentheses. So 1/4 times 4 is just 1. So x plus 2 divided by 4, it's 1/2. And so you have this inside the parentheses, x plus 1/2 inside the parentheses. Then you have minus 1/2 outside the parentheses, and they would cancel each other out. So you have x at the end. And therefore we say that yes, they, well, actually, let me be more specific. Don't use stay. F of x and g of x are inverse of each other. Okay. So to tell, again, to tell whether it's an inverse or not, after you have the composition of the two functions, do you get x by itself? And this is the reason why I told you that you knew an example pairs of inverse functions already, because you know about x squared and square root x. Okay, so if you can use that as your go-to example, the understanding of inverse would be a lot easier.